How do people feel about stuff like the homework that's coming up due this Friday? Okay.
Which works it was? What did we have to with the fourth one and all like sort of expand it out? And I did that. I got a leading constant of -10, but it was incorrect, and I don't know where I went wrong. I rechecked my math. And I used an expanding calculator just to sort of double check to make sure that I wasn't getting tripped up, and that returned the answer. The leading coefficient is -10 too. So I don't know what's going on.
Oh, interesting. So I think here are the things I'd suggest in that situation. You know, like, if you had the web work right in front of you, I'd say, let's look at it. Here are some things to think about. It could be that there's like a wadding issue in how you're interpreting things. And that like, no, the problem's just asking for something slightly different. You've done everything correct, but you've answered a different question. And then also like you went and like grabbed the function you found and the function that was originally given to you to see if they like match up. Yeah, that seems like an office hour thing. How do you feel about my office hour today? It sounds like you've done lots of things that are correct. Let's talk about a few things. I guess one logistical thing. You'll notice that like some things about a midterm that's not for quite a while have shown up on Canvas. So let's just point out what some of those things are. So let's see, I guess that midterm is going to be October 15, so just about a fortnight from today. There's some review stuff posted. It's available in Canvas, but there's also a direct link right there. There's also a set of review questions posted in Canvas where you'll get feedback, and I'll even like use that for some partial points back. A very limited number of points back, but a little something to like help take the edge off stress-wise as you prep for the exam. Cool. So take a look at that at your leisure. And we don't even have all the material for it yet, so some of those questions are, unfair to think about right now. So what have we done so far? We have talked about the idea of if you want to solve a high degree polynomial equation, like a degree 3 equation. If you manage to guess a solution, you can use that to reduce the difficulty of the problem by 1. And what did we do so far? We thought about like factoring by grouping. If you want to factor an x minus 1 out of this degree 3 polynomial, which you know you can because x equals 1 is a solution, one way to try to factor it out is just you brute force it. You start at the biggest terms, you manually insert things so that an x minus 1 will factor out, and you go left to right, and eventually it factors out and you win. There are some other ways to shortcut this, and let's do the first of them. Let's do a little bit of polynomial long division. How do people feel about polynomial long division? How do people feel positively about polynomial long division? How many people feel like polynomial long division is something that they have done at least once? Okay, cool. That's about where I expect people to be. So, let's go through the algorithm that is polynomial long division here. Then I'll take out some scratch paper and we'll just do one more example of polynomial long division, and then we'll come back to this problem again. So, here's the algorithm that polynomial long division runs on. It's just like long division normally. I'm going to take the biggest part of the thing I want to divide into the polynomial. I'm going to compare it with the biggest part inside of the polynomial and use that to like think about division. So, answer me this first. What do you need to multiply x by to get 2x cubed? Yeah.
2x squared.
2x squared. 2x squared times x is 2x cubed. Yeah. So, if you like, what am I saying here? I'm saying that in whatever degree 2 polynomial you get after you do this division, that top term has to be 2x squared. Because it has to be. The only way you can get the 2x cubed is by x times 2x squared. And just like the normal long division algorithm, here's like a bad guess for what the result of division is. In order to revise that guess, I'm going to do some subtraction and then guess again. So I'm going to do 2x squared times x minus 1, and I will subtract the result. So 2x squared times x minus 1 is 2x cubed minus 2x squared. But you need to subtract that, just like how when you do long division with numbers, you do a bunch of subtraction. So when you subtract it, that'll be minus 2x cubed plus 2x squared. There are no x cubes. That's good. Negative x squared plus 2x squared is plus x squared. And now, I do it again. What do you need to multiply x by to get x squared?
X.
Very good. So the next term in the division is plus x. And now, we iterate. Take x times x minus 1. So x times x is x squared. X times minus 1 is minus x, but then I need to subtract the result. So minus x squared plus x. Minus 7x plus x is minus 6x. And now, there's another easy question. What do I need to multiply x by to get negative 6 multiplied by x? Yeah.
Like, where'd you get the negative 6 from?
Oh, it came from minus 7x plus x is minus 6x. So at each stage, you combine together that coefficient that you had already with whatever it is that you need to add or subtract. Cool. And x times minus 6 is minus 6x, so the next column in long division is minus 6. And now you repeat. Minus 6 times x is minus 6x. Minus 6 times minus 1 is plus 6, but I need to subtract the result. So I need to subtract that, that'll change that negative to a positive, that'll change that positive to a negative. Minus 6x plus 6x is 0, but you already knew it had to be. Plus 6 minus 6 is 0. Oh, well that's good. That tells me that like the remainder is 0 after you do the division. Cool. Does that feel okay? And hopefully that felt a little bit familiar. Like polynomial division is something you've done in the past. Let's do one more example just to like practice with polynomial division. And maybe we'll like reach the payoff. What does this mean? When you divide x minus 1 into this degree 3 polynomial, you get that degree 2 polynomial. That means that that degree 2 polynomial times that degree 1 polynomial is that degree 3 polynomial, because that's what division means. So, let's make time to do one additional example of polynomial division. Let's do it again. Let's do polynomial division to compute. I don't know, I'm just going to grab some numbers at random. Maybe this one. Maybe this isn't so random. No, those are 4x to the 4th plus 3x cubed plus 2x, no squared term, plus 1. And let's divide that by x plus 3. Let's just do that division and see what happens. So, let's run the polynomial division algorithm. So I want to take x plus 3, and I want to divide it into 4x to the 4th plus 3x cubed. There's no x squared term, but polynomial long division will like give you a dumb result if you leave out a term. So there are no x squareds plus 2x plus 1. And now we'll go through the exact same steps as we just did. I'm going to keep on comparing the biggest piece of x plus 3 to the biggest piece of the numerator of the fraction. So, 4x to the fourth, what do I need to multiply x by to get 4x to the fourth?
4x to the third.
4x to the third. And now the game is take this, multiply it by that, and then subtract the result. So 4x cubed times x is 4x to the fourth. 4 times 3 is 12. X cubed. And then you need to subtract the result. I'll take advantage of the fact that I've got erasable pens. So those are both subtracted. So you have no x to the fourths and minus 9x cubed. So there's like one step done in this algorithm. I need to do that like 3 or 4 more times. So what's the next term after division?
Minus 9x squared.
Cool. And yeah, we're going to keep on going. Minus 9x squared. So take this, multiply it by that, subtract the result. So I'll break those into 2 steps. I'll multiply them together, I'll write it here, and then I'll do subtraction. Minus 9x cubed. 9 times 3 is 27.
Where do you get that negative 4x squared?
This one?
No, the one on the top, negative 4x squared on the top.
There's no negative 4x squared. I see this positive 4x squared. Is that what you're seeing?
No, okay, so it's negative 9x cubed.
This one is a squared. So there's a 4x cubed minus 9x squared.
We got negative 9x cubed.
Yeah, so minus 9x squared. 9x squared times x is 9x cubed. And 27 came from 9 times 3, x squared. But you need to take that and subtract the result. I haven't changed that into subtraction yet. So both of those were negative, so they'll change to positive. Because I want to subtract them. Alright, so 9 minus 9 is 0. You have no x cubeds. 0 plus 27 is 27x squared. And now you keep on going. What do you need to multiply x by to get 27x squared? 27x. Next term in the quotient is 27x. And you'll notice that some of these numbers are getting big. I did nothing to ensure that this division would work out evenly, so I expect there will be a remainder. And the remainder might involve like a really big number. Sometimes that's life. So 27 times this and then subtract the result. 27 times x, 27x times x is 27x squared, what I expected it to be. 27 times 3 is 81. If you know your powers of 3, then that's quick. Otherwise, you have to do the multiplication. And it's multiplied by x because of that x. And then I need to subtract the result, so that becomes negative, and that becomes negative. And now we keep on going. 2x minus 81x is minus 79x. All right. So what's the constant term in the result of division? So what do I need to multiply x by to get negative 79 multiplied by x? Negative 79. It's one of those questions that contains its own answer. Minus 79. Why is that included? That should be included. Minus 79. Alright, so 79 times x minus 79x. 79 times 3. 27, carry the 2, 237. But I need to do that multiplication and then subtract the result. So whatever it is that I just wrote down there, I need to flip the sign. All right. Now 1 plus 237 is 238. All right. And what do you do with that end result? So just like how with normal long division, you like keep going until the thing you see down here is smaller than the thing you're dividing in. And that tells you like the numerator in a proper fraction that you stick at the end. Same thing here. There's a remainder term of 238. So you have an extra 238 over x plus 3. And I didn't expect this long division to work out evenly because I had no reason to believe it would. So it's not surprising there's a remainder term. All right, so I guess here are some takeaways about polynomial long division. This takes up a decent amount of real estate on the page, but there's a lot of like empty space in it. So what synthetic division does is it's going to abbreviate a lot of this algorithm by erasing all of the information that like gives context to it. And then we'll just have to write less because there will be fewer things to keep track of. So let's introduce synthetic division. So this is just on an extra sheet of paper. I'm going to go back to the notes in a moment. Let's talk about synthetic division. And maybe I'll see the same show of hands. How many people feel positively about synthetic division? How many people feel like synthetic division is something they've heard of in the past? Okay, cool. Let's do some synthetic division. So, synthetic division is what you get if you take the polynomial long division algorithm when you divide by a very simple polynomial. So I guess here's the caution first. There's like a caution triangle. Only for when you divide by something that looks like x minus a constant. In this example, are we dividing by something that looks like x minus a constant? Sure we are. The constant is -3. So here's the algorithm that I'll follow. If I want to divide x plus 3 into this, I'm going to put a -3 out front. And we'll see why the minus is appropriate by comparing it with polynomial long division. I'll put a division box to make it look like I'm doing division. And now I'll just record the sequence of sequence of coefficients of the polynomial. 4, 3, 0, 2, 1. And here is the algorithm that is synthetic division. Step 1. I'm just going to take that 4 and put it up top. Yeah.
Did you just make the x plus 3 into the -3 so it fit this problem?
Oh, this is the same division. So if it's x plus 3 you see there, you're going to put a -3 down there. And in a moment, we'll see why I put the minus right there. So you remember how, like, in all of the steps when we did synthetic division just now, I said, well, I'm going to multiply this thing by x plus 3, and then I'm going to subtract the result. So when I did that, I would wind up multiplying the 4 by 3, and that gave me the 12, and then I had to put a negative sign next to it. Yeah,
If it was x minus 3, then would you put +3 there?
that's right.
Yeah.
So if you wanted to do stuff divided by x minus 3, you would do 3 divided into stuff.
Yeah.
Groovy. So let's carry on and see what happens. So here's the algorithm I'm going to follow. I've taken that 4 and I've put it up top, and that's just because, well, that's that 4. Because where that 4 came from, it just came from that 4. Now I'm going to take that 4, I'm going to multiply it by -3, and I'm going to put it in the next column. And the reason for that is because of that 12. So, doing that, 3 minus 12 is minus 9. Oh, notice that's the same as that minus 9. So the next term in division will be minus 9. All right. And so synthetic division is this algorithm that's motivated by polynomial long division. But once you like erase all the x's, you can just run an algorithm automatically. So the next step is take negative 9, multiply it by negative 3, and put it in the next column. Negative times 9 times negative 3 is 27. Cool. So the next entry is 27. 0 plus 27 is?
47.
Very good. So, wait.
Minus 27.
Ooh, should it be minus 27? Well, let's see, it's negative times a negative. So negative times a negative becomes positive.
Oh, but I thought you like minus that.
No, so that's the point of why there's a minus here.
Oh.
The job of that minus sign is do the and subtract the result step. And so I don't need to remember that manually. It'll be taken care of by the multiplication. Groovy. So take the 27, put it there. 27 times negative 3 is minus 81. And notice this is now hopefully being really reminiscent of the stuff that's happening over there. 2 minus 81 is minus 79, so the next term is minus... Well, I want to keep this in red, I think. Minus 79. Now I multiply minus 79 by minus 3. I've already done that multiplication. It was 237. One plus 237 is 238, so I have a remainder term of 238. And notice, what's written there is now like a box of numbers with a bunch of like arrows and shit on it. It doesn't tell you what it means. So when you do synthetic division, it's important to actually write your conclusion. What can you conclude out of this synthetic division? You conclude that 4x cubed plus 3x squared, nope, 3x cubed, nope, that was to the fourth power, plus 3x cubed, plus no x squared, so I don't need to write that, plus 2x plus 1 all over x plus 3 is equal to 4x cubed minus 9x squared. My cubes look really bad. Plus 27x minus 79 plus 238 all over x plus 3. That's what that division tells you. Neato. So, that was a nice little foray into the algorithm that is synthetic division. There are a few other little supplementary things recorded. If you want to check those out, they're on the course webpage. But for now, let's go back over here and do synthetic division one more time. Do I still need to have the yellow sheet up? Do people still want it up? Okay, cool. I think I can about manage that. No, that's worse. Okay, I'm sorry. Groovy. All right, let's do one more bit of synthetic division. Let's do this same division again, but using the synthetic division algorithm. So, let's divide x minus 1 into 2x cubed minus x squared minus 7x plus 6, and just do it. So, maybe I'll see how people feel. Do people feel like they're comfortable enough that they can run the algorithm on their own? Or raise your hand if I should do it, and we'll talk through it together. All right, then we'll talk through it together. So, step 1 in the synthetic division algorithm is take this number and write it there. And those of you who didn't raise your hand, you have an idea of what to do next. So what's the next step in the synthetic division algorithm?
Subtract 2.
subtract 2, not subtract 2, but add 2, because I see 2 times 1, so I'll put a plus 2 there. All right, and combine those two, so -1 plus 2 is plus 1. So what do I do next?
So plus 1 half over -1.
Put plus 1 on top of -1, and what do I do next?
Multiply 1 by 1. So it's 7 minus -7 minus 1. -7 plus 1.
-7 plus 1, totaling up to
-6.
-6. So what do I do next?
Put -6 over -7.
-6 over the -7.
And then multiply -6 by 1, so we get -6, and 6 by 6 is 0, so there's no remainder.
Nice, so that tells me the remainder is 0. All right, so, but now we wind up in the same boat where that's like a box with some numbers in it. It doesn't tell you what it means. So let's write the conclusion. So, 2x cubed minus x squared minus 7x plus 6 divided by x minus 1 is 2x squared plus x minus 6. Neato. All right, so there's like this long foray into how you do polynomial division. The whole point of doing polynomial division for us right now is it lets us reduce polynomial equations in complexity by 1. And let's see all that happening. So no matter which of these 3 columns you look in, you'll see that 2x cubed minus x squared minus 7x plus 6, you can rewrite that as the divisor, x minus 1, multiplied by 2x squared plus x minus 6. So instead of solving the hard equation to solve, I could solve this equation because it's the same damn equation. That thing I just underlined in blue, is that an easier equation to solve? Yeah, because like if I asked you to solve that, what would you do?
Quadratic formula earlier.
Quadratic formula seems relevant because there's space to expand this on the next page. So since this thing factors as x minus 1 times 2x squared plus x minus 6, you can solve this by saying instead I'm going to solve x minus 1 equals 0 or 2x squared plus x minus 6 equals 0. And both of those equations look easy to solve. And let's start with the easy one. What's the solution to x minus 1 equals 0? X equals 1. The solution that we already had. So that's like not surprising. And you said to solve that quadratic formula? That seemed like a good enough plan for everyone else? So use whatever strategy you want. Solve that degree 2 polynomial equation. Oh, maybe I'll see what strategies people are following. How many people have planned to use the quadratic formula? How many people would plan to like try to factor it? Cool. How many people would like try something else like completing the square? Cool. Any of those are fine. I'm going to stall for a bit, and you are going to tell me what x values this produces. Once you have some x values and you've like compared with those around you so you feel confident, let me know what you get. Cool, what'd you get?
1.5 or -2.
Right here, 1.5 or -2. Do I hear a second for 1.5 or -2? Cool. Do I hear a call for me to do the walk to justify it? Cool, I'll do some walk to justify it. So, numbers look like just complicated enough that I'm going to like give up and just use the quadratic formula rather than trying to factor? Since I know that both of those answers are irrational, I know that this will factor, but let's use the quadratic formula. So let's use the quadratic formula. Quadratic formula says that what are the solutions to this? The solutions are x equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Negatives cancel. Cool. I screw anything up yet? Okay. There's always because like by this time of day I just had lunch, so I'm tired. So it's always dangerous to do it right after that. What number do I wind up with under that square root? 49. Cool. What's the square root of 49? Good enough. Oh gosh, and now the negative choice. Negative 1 minus 7 is negative 8. Divide by 4, that gives me the negative 2. The positive choice. Negative 1 plus 7 is 6. Divide by 4, that's 3 over 2, also known as 1.5. Alright, so we found all three solutions. They're there. We just solved that polynomial equation. That feel pretty okay? Let's do one more all together, and then I'll have you all walk on one additional one, if people would like. Otherwise, we'll move on to the next trick. So here's another polynomial equation. X cubed plus x squared plus x plus 1 equals 0. Let's try to solve that equation, given that x equals negative 1 is a solution. So for sanity check, is negative 1 actually a solution to that? Plug in negative 1, I bet you can do it in your head. Do you get 0? Awesome, cool. That's right, the odd terms will be minus, so negative 1, positive 1, positive 1, yeah, that'll walk into 0. Ooh. Good. Let's do it. So x equals negative 1 is a solution. So what degree 1 polynomial do I know should divide evenly into this?
X plus 1?
X plus 1. So here's the observation. X plus 1 divides into this. And I now have like some choices for how to do the division. We can like go through and do like the ad hoc thing where you like try to factor out an x plus 1 starting with the higher order terms. We can do polynomial long division. We can do synthetic division. Synthetic division, polynomial long division, the ad hoc thing, other things people would like to do. Okay, well, I guess you didn't have to want to do any of them, but we're going to do it. I think the synthetic dividers had it. If you want to do the other strategies, then do it. Hopefully we all get consistent answers. So, x equals negative 1 is the solution, so x plus 1 is dividing into it, so that means I guess I have to put a minus 1 in the box. Out of the box. Minus 1, dividing into, and now the sequence of coefficients. 1x cubed plus 1x squared plus 1x plus 1. Cool. So far so good. And now just follow the algorithm. Step 1, take the 1, draw it above the box. 1 times negative 1 is negative 1. 1 minus 1 is 0, so put a 0 above the box. 0 times negative 1 is 0, 1 plus 0 is 1, so put a 1 there. So the remainder is 0. And that's like really fast. And like, now there's no information there. Now you have to like extract that. So, the polynomial I started with, x cubed plus x squared plus x plus 1, factors as x plus 1 times whatever this means. So let's see. No remainder, constant term is 1, no x's, there's a 1x squared. So there's an x squared plus no x's plus 1. Groovy. Those of you who did anything else like polynomial long division or some ad hoc factoring, did you get something similar? Awesome. All right, cool. So the whole point of doing this is it makes the equation now easier to solve. So I need to solve x plus 1 times x squared plus 1 equals 0. So that means either x plus 1 is 0 or x squared plus 1 equals 0. Both of those look like easier equations to solve than the one we started with. What's the solution to the first of those equations? -1. Not surprising, it's the one we started with. Solve the other equation for me. What do you get?
I,
And?
I.
Yeah, I or negative I. Right? At some point in that process, you undid a square with a square root. So, I'm getting solutions of x equals -1 or plus or minus I. And hopefully the cost of I is sufficiently distinguishable from other symbols. Neato. That feel pretty good? Groovy. And now maybe I'll see how many people so how many people did try to just do a very ad hoc try to divide out from the big terms first? Okay.
You just take x squared out of the first one and then I'm good.
Yeah. Yeah, you actually really can. So let's do it that way. So x cubed plus x squared plus x plus 1. If you gather together those two terms and factor out an x squared, oh, there's an x plus 1 staring at you. Oh, that next piece really is just x plus 1. So you have x squared plus 1, many, x plus 1s. So in this case, doing the ad hoc thing is faster. But there's no promise that it'll always be faster. Groovy, here's one for you. 2x cubed minus 10x squared minus x plus 5 equals 0. Given that x equals 5 is a solution. And we'll see how people feel. People feel like they have the algorithm down well enough that they can just do it? And you want me to at least get us started? Cool. I will just be quiet. You are eventually going to give me a list of 3 numbers. If you come down to a place where you're getting stuck, ask a question. If you're coming down to a place where you have the list of solutions, think about some things you might do to check. Yeah. of something else. Yeah, so you would add, well, x equals 5 is the solution. So that means x minus 5 factors in. That should be a plus 5. Because then you're dividing x minus a constant, and that constant is the thing that goes there. I don't know, that's like the downside of synthetic division. It's really easy to make something wrong because it doesn't on its own make any sense. You have to like know everything beforehand. Yeah.
So when we start this, like when we're dividing, are we dividing by a 5 or a -5?
Ooh, the thing that goes next to it is a 5.
Okay, that's what
We're dividing x minus 5 in, but synthetic division is like the minus 5, the constant is 5.
okay.
Yeah, so let's write that much at least, and then we'll see if people want to come together. So, x equals 5 is a solution, so that means that x minus 5 is a factor. If you want to use synthetic division to do it, it's 5 divides into 2, -10, -1, 5. Or if you do like polynomial long division, you know exactly what you're supposed to write because you just write everything. So let's try to come together. So this equation has like 3 solutions, right? What are they? Yeah.
I got positive and negative square root of 1/2 and then 5.
Nice. You have the one that you all had to operate, and there's the one you had to do some walk on. People agree?
2 and -1.
A 2 and a -1 instead. So, we'll go through and we'll do the walk either way. In order to check, -1's easy to plug in, so I'm going to plug -1 in just to do the sanity check. So that's -2, because it's negative cubed, minus 10, so I'm up to -12, plus 1, so that's -6 plus, I'm getting not 0. So I think it's an issue. I think I lost track of some numbers, but I'm winding up not with 0. So let's go through the walk and see what we get. So did you do synthetic division or something else? Cool, then we'll do synthetic division. So let's follow the synthetic division algorithm. I'll take the 2 and I'll put it there. 2 times 5 is 10, so I put a 10 there. Adding up to 0, cool. So the next term is 0. 0 times 5 is 0, so I put a 0 there, so there's a -1, there's a -1 that comes up there. -1 times 5 is -5, so the remainder is 0. It's worth computing the remainder because there's enough steps in this that you can screw something up easy enough. The remainder is a good checksum.
That's what I got, so I guess it's sort of trying to see, because sort of I had an issue with sort of translating that into final version. Would it be 2x cubed minus x?
2x squared minus x. So there's like the constant term, there's the x term, this is the x squared term. So 2x squared, not minus x, 2x squared minus 1. So the new equation I need to solve is 2x squared minus 1 times x minus 5 equals 0. So 2x squared minus 1 equals 0, or x minus 5 equals 0. And now that we've written those two down, do those result in those two solutions that I claimed? Awesome. I think instead of spending 3 minutes starting it on the rational roots test, here's a different thing that I'll do. At this point in the class, I wouldn't take off for this failure to simplify a final answer. But later on in the semester, like after we start doing some trigonometry, if you give me that answer, I'd say, nah, you should simplify that and like take off a point. So let's talk about how to simplify that. So there's some things that I don't like to see involving square roots and fractions. I don't like to see fractions inside of square roots. I don't like to see square roots in the denominator. So let's fix both of those things. So instead of square root of 1/2, let's make that the square root of 1 divided by the square root of 2. And like, you certainly can do that. Square root splits over division. Not over addition or subtraction, but multiplication and division are nice. It looks like I just made it worse, not better, so that's annoying. But what's the square root of 1?
1.
1. And I still have like a square root in the denominator. I don't like having square roots in the denominator. So you remember how like when doing complex arithmetic, when you see a complex number in the denominator, you like multiply and divide by the thing that makes the denominator nice? Let's do the same thing here. What's a nice thing to multiply by to turn the square root of 2 into something nice? Exact same thing. Square root of 2 times the square root of 2 is 2. Times root 2 divided by root 2. Gosh, 1, square root of 1 is 1, square root of 2 is the square root of 2, so that's just the square root of 2 in the numerator, and in the denominator I see 2. So this one I'd want to simplify to plus or minus root 2 over 2. And that's a worthwhile thing to do for a few reasons. One of them is if, say, you and someone else are independently finding solutions to equations, if you both agree you're going to put your answers into simplest form possible, and then you compare answers, then you'll be able to visually compare answers and say, yep, our answers agree, without any decimal approximations. Groovy. All right, as y'all are packing up, take a look at stuff like stuff on wall. Ask me some questions about that. If you do want to talk to me about that web work problem you're having an issue with, which it sounds like it might be like just a web work issue. I've got my office hour at, when is my office hour? Is it in an hour? It's an hour from now, right?
It's in 10 minutes.
It's in 10 minutes. Why isn't my alarm going off?
It's supposed to be, I think.
Because my cell phone's in my office. I'm just annoying my neighbor.
So, quick question. I know in the Weber homework it mentions something about having like a group activity Friday. I'm gonna be out of state. Is that something that like I can make up? It's totally okay if not. But
Yeah, it won't be like a group activity. What's the reason you're out of state?
I'm gonna be in New York.
For an officially excused reason or for
Not
fun?
officially, no.
Okay.
It's just the only time my friends and I could go before my friend moves to Korea.
Yeah, fair enough. Yeah, so shoot me an email telling me that, and also telling me like a bunch of times that you can make it up on Monday.
Okay,
And then what I'll have you
absolutely.
do is it'll be like an individual activity, which will be, less pleasant.
Okay, yeah, so can do it. Awesome. Thank you so much. I appreciate it.
Groovy.
What time's your episode?
Apparently it's like 10 minutes from now.
Oh, neat. Cool.
You want to come chat?
Maybe. I don't know.
All right. Well, I guess you got some time to make that decision, but not a lot.
I'm curious. Did you guys